Alright, so our first joke for today is what kind of computer sings? So here's a computer. I tried drawing a computer earlier, it didn't work very well. Alright, let's draw some notes for it. Some music notes, it's singing. Okay, so there's some music notes, it's singing. Alright, and the kind of computer that sings is a Dell. Do you get it? Like the music singer, Adele, like Adele, like a Dell computer. So funny. Okay, so your frame for today is about approximating square roots. Alright, and approximating square roots is about understanding the order of real numbers to estimate square roots. Alright, before we start anything, let's talk about what a square root is. A square root is a number that you can get when you multiply a number by itself. So those squares, like ones. So down here we're going to talk about perfect squares. Sorry. Okay, so perfect square is a number that when you square an integer, you get it. So like 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. Remember that squared sign means we're multiplying it by itself. So like 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, okay? Then we have 5 squared, or 5 times 5, which is 25. 6 squared, which is 6 times 6, or 36. Okay, then 7 squared, which is equal to 49, or 7 times 7. Okay, 8 squared, which is equal to 64, or 8 times 8. 9 squared, which is equal to 81. 10 squared, which is equal to, 100. Let me run over here. 11 squared, 11 times 11, which is 121. 12 squared, which is 144. 13 squared, which is equal to 169. 14 squared, which is equal to 196. You need to fit one more in there. 15 squared, which is equal to 225. These perfect squares, which is the 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 186, and 225. Those are what the perfect squares are, okay? We're going to be using those a lot in this frame. These numbers are ones that you should memorize. If you see 81 written down somewhere, you should be able to say, oh, that's 9 times 9. Or if you see 169 somewhere, you should say, yep, that's 13 times 13. Excuse me. Excuse me. So we go up to the top. Our steps for approximating the square roots is the first step is what squares sandwich the number. Okay, so what squares sandwich the number? The second step is to simplify radicals. The third step is which square is it closer to? that step, what you're actually going to do is a number line. Okay? Then step number 4 is going to be estimate. Sorry, I'm getting sick here. Ugh. Okay, so you might be wondering about what some of this means, so hopefully I'll explain it. So the first one we're going to do is we're going to estimate what the square root of 17 is. Okay, so that square root sign is actually called a radical. Okay, what the first step is what squares sandwich the number. This would actually say what perfect squares. Sorry, what perfect squares sandwich the number. So we need 17. So 1, 4, 9. Oh, 17 is between 16 and 25. Okay, so square root of 16 is less than the square root of 17, less than the square root of 25. Okay? Number 2 is simplify the radicals. So we simplify the 16, which is actually 4. We're going to keep that middle one because we don't know it yet. And then simplify the other one. So we know that the square root of 17 should be somewhere between 4 and 5. Alright, it is going to be an irrational number because 17 isn't a perfect square. Okay, number 3 says which square is it closer to? So we're going to draw a number line. Really quick one. Okay, so if this is about 16 here, it goes like 17, 18, 19, 20, 21, 22, 23, 24. Here's 25. Alright, 17 lands right here. Right there, 17. Okay, so 17 is there, so it's closest to 16. And it's really pretty close to that, so it's going to be pretty close to the square root of 16, which is 4. So we're going to estimate about 4 and 1/10, or 4.1, okay? That's because it's really close to that 16, so the square root of 17 is going to be really close to the square root of 16. We're going to use our approximating signs, which is an equal sign but squiggly. That means about 4.1. Okay? Number 2 is going to be the square root of 47. Oops, square root of 47. The first one is to find out which two numbers it's between, which two perfect squares. We scroll down the bottom. 47 is between 36 and 49. So the square root of 36 is less than the square root of 47, which is less than the square root of 49. Okay? So, then you simplify the radicals, which is the square root sign. So we're going to simplify the outside. The square root of 36 is 6, which is less than the square root of 47, which is less than the square root of 49 is 7. Then we're going to find out which perfect square it was actually closer to. And that's going to tell us which number it's closest to, 6 or 7. Okay, so this is about 36. 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay, 47 is right there. That's supposed to be an arrow. That's 47. So 47 is closest to 49, and it's pretty darn close to 49. So it has to be pretty darn close to 7. But it can't be over 7. So when it can't be over 7, it's going to be 6 point, and then a decimal that's going to be really close to 7 would be about 6 and 9/10, or 6.9. Okay, so we're going to say this is approximately 6 and 9/10. Okay? And then we have the square root of 116. Okay? So we have the square root of 100. Oh, we've had to find the two squares that's in between. It's between 100 and 121. Okay, so square root of 100 is less than the square root of 116, which is less than the square root of 121. Okay, we simplify those end radicals, so 10 is less than the square root of 116, which is less than 11. So instantly we know our answer has to be 10 point something. Because it can't be 10, it has to be bigger than 10, but it has to be less than 11. So it's going to be 10 point something. Okay, so we draw our number line. Okay, this one I'm going to go by fives. So here's 100, 105, 110, 115, 120. So 121's pretty close to here. That's 120 there. Okay, 116, well this is 105, 110, 115. 116's pretty close to 120. It's still a little bit farther away. So instead of going all the way to that 0.9, let's say it's about 10.8. It's a little bit farther away than it could be, but it's still closer to 11. So it's approximately 10.8. Okay? We're going to do one more example. I know there's two more on here, but we're just going to do one more. Okay? Let's do the square root of 6. Okay, so first thing is to find what two numbers it's between. It's between 4 and 9. So the square root of 4 is less than the square root of 6 is less than the square root of 9. Okay, so 2, simplify it, is less than the square root of 6, which is less than 3. Okay, so it has to be somewhere between 2 and 3. So our answer is going to have to be 2 point something. Okay, when we make a number line, here's 2, oh, I'm sorry, we start at 4. Here's 4, 5, 6, 7, 8, 9. Okay, and here's 6, right? Here's 6. Okay, so it's not quite halfway, but it's almost halfway. Halfway would be that 0.5, so almost halfway would be about 2.4, 2 and 4 tenths. Okay, we're not going to do those last two examples because I want to make sure this video is within a timely manner. So we're going to go down to the so what part. So what? It is important to know your perfect squares. Okay, it's important to know your perfect squares, and remember, .5 or 5/10, that's half. So if is half. Okay, so if a number is over halfway to a certain number, then it's going to be over 0.5. If it's less, then it should be under 0.5. All right, thank you. Have a good night.